Imagine waking up one day and finding your compass pointing south instead of north. No, you are not in a parallel universe. Welcome to a day when the North and South poles have swapped places. You see, this isn't the plot of a new science fiction movie. It's a real scientific phenomenon known as a geomagnetic reversal. That's right, the Earth's magnetic field has a history of playing musical chairs, flipping north with south and vice versa, multiple times throughout our planet's past. Picture this, birds going on vacations they never planned, flying in utterly wrong directions, or GPS systems throwing tantrums, causing utter chaos on our roads and in our skies. A laugh riot, isn't it? But it's not entirely impossible. So how do we know that this could happen? It's all thanks to the rock-solid evidence, literally. To understand how scientists know about these reversals, we need to delve into the world of paleomagnetism, or as I like to call it, the study of old rocks with a magnetic personality. Picture this, a bunch of scientists huddled over rocks, deciphering the secrets of Earth's magnetic history. How does it work? Well, when molten rock cools and solidifies, it locks in the direction of the planet's magnetic field at that moment. By studying these rocks, scientists can map out the past orientations of our magnetic field. Now let's get to the heart of the matter, the center of our planet. Earth's outer core is a swirling sea of molten iron flowing like a metallic river. As it moves, it generates electric currents, which in turn create our planet's magnetic field. It's an ongoing, dynamic process like a self-sustaining dynamo. So what about these magnetic field reversals? Well, they're not as rare as you might think. Research published in the Geological Society of America bulletin states that magnetic reversals have occurred at irregular intervals throughout Earth's history, with an average rate of about 3 times every million years. However, the last reversal happened around 780,000 years ago, which means we're somewhat overdue for a magnetic makeover. These reversals, or geomagnetic flip-flops as I like to call them, aren't sudden. They take thousands of years to complete. The field weakens, becomes chaotic, then gradually realigns in the opposite direction. It's like a compass having an existential crisis before deciding that north is the new south. But why do these reversals occur? Well, that's the million-dollar question. Scientists believe it's due to complex changes in the flow of molten iron within Earth's outer core. However, the exact mechanisms are still a mystery, a puzzle waiting to be solved. So, we've got the evidence, but what happens when the poles do decide to flip? As fascinating as it sounds, a pole reversal isn't a one-day event. It's more like a very slow and lazy flip-flop that takes thousands of years to complete. Now, wouldn't it be a spectacle if it were a quick switch? Imagine, one day you're in New York, sipping your morning coffee, and the next thing you know, you're in Antarctica, making friends with the penguins. Talk about a chilly surprise. But let's get serious, or as serious as we can get when talking about a sloth-paced pole swapping. What happens to our climate? Well, scientists believe there might be a slight increase in solar radiation hitting the Earth. But don't worry, we're not talking about turning into a second sun. More like a minor sunburn if we forget our SPF. And what about our wildlife, especially those migratory birds that rely on the Earth's magnetic field for navigation? Well, those little avian adventurers might find themselves on a detour. Picture a Canadian goose ending up in Hawaii instead of Mexico. Not a bad trade, eh? Lastly, our technology. You know, our beloved GPS might just have a meltdown. It would probably start directing us to the nearest coffee shop in the Arctic. Now that's what I call a cold brew. So while it's unlikely we'll wake up to a flipped world tomorrow, it's a fascinating topic to delve into, don't you think? Now that we've navigated the flipping poles together, it's your turn to join the discussion. Have you got any burning questions about this polar switcheroo? Or perhaps you've got some icy cool theories of your own. Don't keep them to yourself. Drop them in the comments section below. Let's keep this conversation flipping fantastic. If you enjoyed this video, show us your love by pressing the like button. And if you don't like this video, show us some love by, you guessed it, pressing that like button anyway. So in the end, it all comes down to that like button. Thank you to all of you.